Okay, so this is an interesting graph because it makes you believe that Z has more red candies, okay, than the other two bags. But you have to be careful is relative frequency. So the deal is here that if brand X has 30, but brand Z has 10, so here, this for brand Z, 60% could be 6, but here 40% could be 12. Okay, is relative frequency, it's not the number. So it cannot be one where they compare the number of candies from one bag to another. And so see, there's more candies in brand X to brand Z. Here is the blue candies in X to Y, and the number of Z and the number of the other two bags. We can't do that. We can only compare to each other. All right, so taking that in consideration, we're down left to A and B. All right, so let's just go. So what do we have here? So they say that brand X are more green than there are red. So this is what, 40%? And this is 10, roughly 40%, 25%. So there's more green than red. Okay, that's not true. And brand Y, there are more red candies than there are green candies in the bag. So the answer is B. So what is there here, like 50%? And then this is what, up to 80, so this is 30%. Remember, it's percents. So the answer is B. Okay, so this is a SAW for the sample size. You know, I think I've seen one in each test, so you should expect one tomorrow. And remember that because we're dealing with the means, okay, that is going to be the margin of error is equal to T times the standard error divided by the square root of n. So because T relies on n, remember we're not going to use T, we're going to use Z. Okay, so my margin of error is 5. Okay, Z for 90% is 1.64. My standard deviation is 35, and it's divided by the square root of n. Okay, so now it's just an algebra 2 problem. So I'm going to divide both sides by 1.64. So 5 divided by 1.64, I get 3.048. 3.04 is equal to 35 divided by the square root of n. These guys do the do-si-do. So I get the square root of n is equal to 35 divided by 3.04. So I get 35 divided by 3.04, and I get 11.48. So I get the square root of n is equal to 11.48. And so I square both sides. Okay, we're just going to do math. And I get 131.7. So the answer is C. Okay, so this is interesting that, what is it, that the sooner a cub is likely to play, the more time a cub plays, the more likely he's going to start to hunt. Okay, let's look here at the male deal here. Do you see that it doesn't really seem to make a difference? Because whether they play for 3.5 or 5.1, they still all hover under 14 months that they start to hunt. So I don't think it really matters for males. So anything that has for males in it, here that the equivalent, okay, both evidence for the male, okay, well, maybe D and maybe E. So let's just go look at here. But look at the females here. That for 3.5 is 13 and 3.7. See, there is evidence for the female, so the answer is A. Okay, so number 30 is basically defining what a 95% confidence interval. Read all of them. The answer is D.